Hello students, welcome back to OrganiChemVerse. Let's see which of the given reactions will not yield 2-pentanone as a product. So let's analyze the reactions one by one. The first reaction is between a Grignard reagent and an amide. The Grignard reagent given here is a propyl magnesium bromide. It is treated with an amide, that is N, N dimethyl ethanamide. Now, what should be the reaction? When these are taken in an ether, which is a solvent, then the negative charge will attack the CO carbon and the nitrogen will leave as a good leaving group. Then what product do you expect here? The CO group will remain as it is, right? With the methyl, and the carbon-carbon bond formation is happening here, and then the product formed here is a ketone and it is 2-pentanone. Therefore, the first option cannot be the right answer. Let's check for the second reaction. There is a ethyl bromide. It is treated with the Keto-ester in presence of sodium ethoxide in ethanol. What should be the first reaction? If you are not understanding what to do here, very simple, you just try to polarize the molecule. Say bromine is electronegative, so partial negative and this is partial positive. Now, we are using ethoxide. Ethoxide is a base. That means it has to abstract the proton. It should take the acidic protons. Where do we have acidic protons? So these alpha hydrogens are acidic in nature, right? Why so? When ethoxide takes the hydrogen here, the formed carbanion. So I'm going to write it like this. See, when ethoxide takes it here, the bonding electrons will be given to the carbon. So what we are going to get here is a carbanion which is stabilized by two functional groups. One is ketone like this, the other one is ester. So because of this, what happens? This carbanion is quite stable, right? So that's why it is being formed. Now what do we have here? Ethyl bromide. So the negative charge will attack the positive carbon, right? Bromide is a good leaving group. It will leave the molecule. So what we are getting here is a product like this, right? So there are two carbons, so CH2, CH3. Now the reaction is not yet over because there is a H2SO4 water. That means it is acidic hydrolysis and this is an ester. So when ester undergo hydrolysis, what happens here? It's going to form the carboxylic acid. And this carboxylic acid is nothing but it's a beta keto carboxylic acid, and they are not so stable because they can undergo decarboxylation easily. So because it is undergoing decarboxylation, so what product are we going to get here? We are going to get 2-pentanone as a product. 2-pentanone as a product. Therefore, this is also not the right answer. So it has to be either C or D. So let's analyze that. The reaction C and D involves the addition of water across the triple bond for one pentyne molecule but under different reaction conditions. So let's see which of the given reaction conditions will give 2-pentanone and which will not. When we add the mercury acetate in acidic medium and water for one pentyne, it will undergo simple Markovnikov's addition of water across the triple bond. So what happens is at the terminal carbon, the hydrogen will go as there are more number of hydrogen on this carbon, and the OH will go where there are no hydrogen. So how many carbons? 1, 2, 3, 4, 5. Still there are 5 carbons. So this is enol. Enols are not stable, so it will undergo tautomerization and it is forming 2-pentanone molecule. So at the second carbon, there is a carbonyl, therefore it's forming 2-pentanone. So then C is also not the right answer. So it has to be D. So let's verify that. In presence of borane in tetrahydrofuran followed by peroxide and basic medium, it will undergo anti-Marconica's addition of water. That means what? Here we are adding H, right? But instead of that, we are going to add OH here. Here we are adding OH, but here we are going to add the H. So this also will undergo tautomerization. So since it is happening at the terminal carbon, so what happens here? We are going to get the carbonyl, and this is nothing but 1-pentanal. 1-pentanal, right? And what about this? This is 2-pentanol. So which reaction is not forming 2-pentanol? The last reaction. Reaction D will not form 2-pentanol. I hope I made this clear, and if you still have any questions on this, you can comment your queries in the comment section, and don't forget to subscribe the channel. Thank you.